Hi, good morning. I am Sujay Sarkhel. I work for Oracle's Internet of Things Cloud Service. And this bonus session is about introducing the, the perspective of using the cloud service and making sense of the real-time streaming data from your devices. So before I get started, a safe harbor statement that Oracle wants me to present says that, everything that I'm going to talk about is just an outline of the general product directions, and it's just for information purpose only. So as I get started, one of the perks that I have as part of working for, IoT Cloud Service is that one of the questions that I get asked pretty often is, how do you really define IoT? What is Internet of Things? And it's a very interesting question because, if you do a little research online, you would find that people have different perspectives in defining Internet of Things. On one end of the spectrum, you have folks thinking about IoT as, an efficient way of, interconnecting devices, machine-to-machine connectivity, machine-to-machine communication. On the other end of the spectrum, you have folks who define Internet of Things as a transformational intercommunication between, sensors and devices on one end, and your enterprise software and hardware. And at the end, the benefit of it is a quantum shift in optimizing business processes. So, it's really, there's not a single statement through which you can really define IoT. To me, it's much more of a technology paradigm. And if you notice, IEEE came up with this page a few years ago saying, and it was actually a contest at that time, asking folks to contribute to the ever-changing, definition of IoT. And even today, this page exists. So, I can probably conjure a definition up for you based on the domain that you're interested in. But it's pretty much a very use case specific term. Much like cloud in itself, how do you really define cloud? But, despite all the hype, despite the buzzword about, Internet of Things, do we really have an answer of, what are the value proposition of IoT? Does it really make sense to have an IoT solution? Does it make sense to move from on-prem to a cloud service? And as we are working with our vendors, with different customers, we're seeing IoT as being an enabler in new business models. The sheer amount of data that you can capture from sensors and devices, the amount of predictions that you can do on real-time volatile data coming in are actually enabling different types of business models. For example, folks are moving from a scheduled maintenance, fix when broken model to much more of a prescriptive, predictive maintenance model. Instead of under-servicing your assets, for example, you can service them on the fly. You would see organizations moving away from ownership model to providing service as a model. And we have been working with aviation folks from the aviation sector, folks from who creates turbines. People are moving away from really selling their products to really selling the services out of them. For example, one of our customers in the aviation sector, they told us that 50% of their revenues right now are from services that they provide, and over the years they're actually moving towards improving that model to having 70% revenues from their services really. people are not looking at static analysis, but really, getting to look at the volatile data that's coming in from the sensors and, performing real-time big data analytics on top of that. One of the fine examples is the insurance sector, for example. We are seeing folks using, different, onboard diagnostics on cars, getting sensor data from those cars and marrying it with, whatever data they have, historical data that they have got in the past, to really predict, drivers, to really predict, different use cases around, how your car is performing, for example. And these are some of the tangible benefits of IoT. For example, if one of the things that that we have seen while working with our digital field services team is, what if you could remotely monitor the operations of your distributed assets? And this is pretty important because, as companies scale out, you would find that, the number of devices that are there, that you need to monitor increases exponentially. So, servicing them becomes a big challenge. What if you could, resolve your service request remotely? And the advantages of doing these, online is, you improve machine uptime. You, for example, improve the service levels. You're actually, at the end of the day, improving customer satisfaction. On top of that, add predictive analytics for the data that you're getting, and using that prediction to find out, hey, what's the failure rate of my devices, and servicing those assets over there, and that really improves your service productivity. It actually reduces the failure rates for your devices. So, with that in mind, I wanted to start off with a demonstration of this entire use case. What I'm going to demo to you is a solution that we have created for the digital field service perspective, and what I'm going to show is a digital dashboard which streams real-time data coming in from assets. We are leveraging IoT CS as your platform, and we're actually integrating IoT Cloud Service with other Oracle IoT products. For example, the Oracle Service Cloud to generate incidents on the fly, to integrate with Oracle Field Service Cloud to create work orders and dispatch technicians to actually service your assets. So let me start with that demo for us for a minute, and I'll come back to the presentation. So what I have over here is this dashboard running in from an iPad. And over here, I'm actually showing a persona of a service manager who is responsible for managing assets across geolocations, And, over here, I'm actually showing you real-time, data coming in from your assets. And over here, I just have 3 assets spread across different geolocations. Lisa is actually monitoring some of the key KPIs that your devices are reporting from different sensor values. For example, hey, what's your uptime? What's your performance? And on top of that, we are actually integrating with other cloud services to generate incidents, for example, based on how your assets are performing. So what I've done over here is actually have a simulator running which simulates a pump which is capable of sending data to the cloud service. So let me start running the pump, and let me show you how you can actually monitor this device from your dashboard. So over here, what Lisa sees almost in real time some of the key parameters that my device is reporting. For example, this blue pump reports the temperature, the bearing temperature, the motor frequency, and stuff like that. And these are actually being streamed in live via the platform. So you have your your devices, in the blue pump, for example, working in a different geolocation, sending that data to IoT Cloud Service, IoT Cloud Service looking at the data and dispatching it via appropriate integrations to this iPad, which is connected to the cloud service, and gathering data from the service itself. Now, imagine this pump as it works for hours and hours. There can be possibly some minor issues that show up. So what I've done in this simulator is I have actually created some simulations for some of these erratic behaviors. And these are sometimes pretty much hard to find because, it might not be possible to just visualize, what's going wrong, but, your sensors might be giving you small signals as to, hey, something is happening with your pump. The temperature is probably increasing on your bearings and stuff like that. So let me actually start, simulating one of those, one of those use cases. And what you eventually see over here is your, hopefully soon. Yeah, so what is happening is the cloud service is slowly monitoring the trend of your data, and we have actually a prediction set up on the trend of the data that we are seeing. And what is happening right now is Lisa is looking at the at the device itself and the prediction on top of it. Right now, what's saying that, hey, there is some data that is coming in from your device which shows that something has happened to your motor, and there is a failure probability of 27%, and probably it's going to fail within 8 to 24 hours. And since it's like actually giving you the data in near real time, you'd see that the trend slowly goes up and down because based on the frequency of the data that you're receiving, you're actually performing analysis on top of that. But right now it shows that your asset is probably not in a very good condition. So what we have done is we have actually used policy automation to actually detect such situations and automatically create incidents on top of that. So this is something that Oracle Internet of Service automatically does with its integration with Service Cloud. So over here, what we have done is, we have actually created different incidents based on, different, incidents, different, sensor values that we have seen. One of the things that, we just created right now is based out of the simulation that I just created. Some erratic behavior on your blue pump. And what we can do with this integration, for example, is we can provide the user with different steps to help resolve such a situation. Over here, we are actually providing the user with capabilities like auto-resolving the issue or a guided resolution. And you can even also, because of the integration with Service Cloud, you can actually look at the knowledge base, for example, and look at, hey, what does erratic motor frequency really mean? Since it's a medium priority incident, let me see if I can actually auto-resolve it. So as part of the auto-resolution, what we are really doing at the back end is we're looking at the trend of data. We are seeing, hey, whether we have seen incidents like these before, and what are some of the resolutions that have been taken so far, and based on that we actually come up with recommendations. So in this case, what it says is, there probably might be a software version mismatch, and it needs to be recalibrated. So we can actually on the air, over the air, really try to auto-resolve this incident. So let me give that a shot. Let me try to auto-resolve this incident. So what is happening right now is, from my iPad, I'm actually triggering, an operation on a remote device via the cloud service. So it's just not one-sided. We're not only getting data from the devices, but we also have the capability of sending commands to it. So, think of the fact that, we really didn't have to send, a field service technician for small issues like this. We could actually look at the trend that has been presented to us, and we could actually resolve that incident on the fly. So that in itself is a big benefit. Imagine, well, something major had to happen. For example, let's say, there's a high severity pump failure that is being reported. So, and this can be, these are not that often, like, these are rare events, but, it can probably happen to your device. And, if I go back to the screen, you would notice that, we have actually detected that as well. And in this case, what has been reported is a high probability of failure. So, the time to failure is from 0 to 8 hours, and it's high time for the service manager to really look into, hey, what's going wrong, and take corrective actions. Similar to before, we see that hey, there is a severe incident that has been reported, and at the time of incident, we see that the failure probability was 95%. Currently, it's at 99%. So it's going up and up and up. So what we can do is we can actually do a guided resolve. What guided resolve is, it actually uses policy automation on Service Cloud and its knowledge base to actually present you with a few options of like what you can really do to correct or mitigate the current situation. So it asks you for a few questions. For example, has the noise level in the pump increased? And we can actually look at the real-time data over here to actually make selections. So let's say the pump noise level has increased. Vibration probably yes. Temp power, for example, I don't think so. So let's keep that as no. And is the pump running slow? Probably yes. So once I submit this, what the service is really doing is looking at your answers, creating a model out of that, and providing you with a set of recommendations. So for example, over here, one of the recommendations that it has provided me with is, hey, there probably might be a potential damage to the main bearing shaft, and some of the recommended actions are, hey, reduce oil viscosity, speed up the pump to reduce friction damage, and create immediately dispatch a service technician to carry out services. I can choose to accept these recommendations. So in this case, if I actually choose to accept this recommendation, what happens is it does a couple of things. It actually talks to your device. It actually reduces the viscosity of your on your pump. I have no idea how it does it, but let's assume that that's a possibility. And also, what it does is it actually creates a work order on the fly. So in this case, it's actually talking to a different cloud service. It's actually talking to the field service cloud, and it created a work order. So a service technician, for example, in his using his own device, can come in, look at the existing work orders, and hopefully look at the data as Lisa is right now, and go to the asset and perform appropriate maintenance. So it's really more about moving away from a scheduled maintenance to a prescriptive maintenance model. Now with that, let me get back to my demo.
Maybe let me interject a little bit.
Sure.
Is that
Go
okay?
ahead.
It may be questions you might have right now as you see, though, and I'm going to pretend I'm also part of the audience. So, Sujay, is this a product, what you just showed us? What is this?
It is actually a product, a solution, really. We have actually created this solution with IoT platform in the base. And leveraged all the applicable integrations that we have to really show you how you can use the data that you have and create talk to your device at one end and also talk to your enterprise applications on the other end.
So then you're using the IoT cloud as a backend as a service, and you implement it with this application.
Correct.
That also can be implemented
exactly.
in any other. All
exactly.
Right. Yeah, go ahead.
Could you talk about some of the architecture components? So is the device data streaming directly to cloud, or you have some edge devices as well?
Good question. So let me actually talk to you about that with my tech stack, which is going to be my next slide. So, one of the things that we see while talking to our customers are we have the solutions that we have created, but like really how do you go about it? How do you really have my sensors, my edge devices, my gateways really talking to each other? So what we did was we actually came up with a set of libraries, client libraries, which you can actually use for your devices. We are actually working with our several OEMs to actually have these client libraries integrated as part of your devices. So, for example, you have your smart devices, and we have our libraries written in C, we have it in Java, we have in POSIX, so essentially, and also in Android. So depending on what your technology stack is, you can actually use one of our client libraries to really connect your device, get the sensor readings, and the client libraries provide you with an abstraction with a set of APIs through which you can actually send that data upstream. On the other side, we have the enterprise libraries. These are actually meant for really monitoring your devices. So on one end, the question that we are trying to solve is, hey, how do you really make your edge devices, your gateway, gateways really send their data upstream, and for that we have our device libraries, which help you with device authentication, exposes device capabilities. One of the capabilities that I showed right now is turning on and turning off your blue pump, for example. On the other end, we have our enterprise libraries, which actually talk to your cloud service, but with a different perspective. The perspective over here is, how do I monitor all these assets? What are these assets telling me? What are the capabilities that each of these assets really has exposed to the cloud service? And all those monitoring framework, so to say.
So the app you showed before,
yes,
you're using the IoT Cloud Service, and then you're using, I assume, the REST APIs to build on top of that?
That's correct.
That's the iPad application that you showed?
That's correct. So what I did as part of my application is Lisa, who is using the iPad, she's actually using our enterprise client libraries to monitor her assets that are spread across different geos. The simulator that we showed was using the device libraries. We were actually using the JavaScript client libraries to connect and send the data. Just to give you an example of how easy it is to really connect, this is a code from our JavaScript client library. What we have done over here is we actually activate our device using JavaScript. So we actually create a virtual copy of your device. We try to connect to the cloud service and send an activation request. So what is happening internally is it's actually establishing a trust between the devices and the cloud service. There's a whole set of steps that have been abstracted out over here, and once the device is activated, what we can do is we can expose the capabilities of these devices to the cloud service. So essentially, we are telling the cloud service, hey, you can now that you have started trusting this device, you can actually turn it off, turn it on, change different parameters of the device, or even accept information that I am sending you. So what we do is we expose a concept called a device model. A device model is nothing but a metadata about the different types of data that you can send upstream. So over here, what we're saying is, hey, I'm actually creating a metadata with respect with this device model, and I'm actually using it to send data upstream. Once the device is activated, this is an example of how you can really, then send the data. Here, I'm actually creating a new message, just a simple string message. And I'm actually, using my virtual device that I've created before to send some update request. And, this is just a pure simple JavaScript example. You can actually use something like a Raspberry Pi or any, other devices that you have, C code, for example, on top of that, to actually send real-time data about, your devices upstream. So, Noel, do you want to?
Sure, yeah.
Show.
That's a good.
How
So,
you do that?
Noel Portugal from the UX team, applications UX team. We are running a workshop. Actually, if you guys go around the hall, and you guys are going to be able to, if you stop by, we can provide you with a kit similar to this, so you can connect to the IoT cloud. So what he just mentioned, we have a Raspberry Pi running. I don't have, the cable is not long enough. But this Raspberry Pi right now is using that client library. And what you see on the screen right now, this is the actual IoT cloud. And if you see, I have the auto refresh interval to 5 seconds. So I'm constantly sending messages. Now, what I have here on the Raspberry Pi, I have a couple sensors. I have a light sensor, I have a button, and also I have a pot switch, kind of like a volume. It's an analog switch, so I can do different values. As I move it, it's going to send the data into the IoT cloud, which it's doing right now. If I just show you the payload right here, you see the angle, the light. Let me just remove auto refresh. Angle, light, if the button was pushed, and the message. Now this is where we're using this very cheap Wi-Fi module. This is under $5. It's probably $3. You can program it with Arduino, and this is what you can get home if you walk by and do the workshop. And it's connecting using a messaging system to the Raspberry Pi, and then the Raspberry Pi in turn connects to the IoT cloud. So it's just a very simple example so you guys can get your hands on. You don't have to be very technical. There's a tutorial there, and we'll be helping you how to get it. And you can go home and play more with it. Yeah?
So once you get these, I would say, technical gadgets, right, what cloud do you have like a developer cloud where we can actually do some hands-on experiments? Or how does it work?
So we actually, Oracle IoT Cloud Service has trial editions. So you can go to cloud.oracle.com and request a trial. And you can get started with that. Also, the cloud service also provides you with the simulators that I just showed. So if you really don't have any devices to get started off, you can actually use the simulator to simulate the data. So and some of the use once we start working with the vendors, what we really do is we actually ask them to use the simulators first, get their device model metadata correct, and then start hooking onto real devices, and use that devices then to send the actual data from device onto the cloud.
Do you need like a high-end device, like a machine, or a simple, let's say, home-use laptop can work?
You can use a Raspberry Pi. a $35 Raspberry Pi and you can send data. Anything that you have through which you can actually use a Wi-Fi model to send data, for example, you can use that. So that's correct. So on the cloud, what we actually do is once you have registered your devices, we actually create a virtual copy of your device. So essentially, all the analytics that we do is on that virtualized copy. So, as soon as we start getting data, we actually update that virtual copy, and that is actually referred to as the device virtualization capability of the cloud service in itself. Sure. So going back, now that Noel has given you an overview of how easy it is to really connect your devices and send data, hopefully this will come up soon. Okay. Now that you know how you can really connect your devices, send data upstream, the next logical step is, hey, now that I have my data, how do I really perform analytics on top of that? So what IoT Cloud Service really provides you are two specific capabilities. One is to perform real-time analytics on your streaming data, and this is pretty much useful when we're dealing with data that is really volatile. It really makes sense for the period of time that streaming. It probably might not mean a lot in historical perspective. For example, the failure data that I just showed you. It's just applicable for that instant of time. On top of that, since we are actually gathering the data, we can actually store that data for historical analysis. For example, the predictions and anomaly detections, they all depend on historical data. And one of the things that that you saw some time ago is the prediction capability. So what we have done is we have actually created models based on the historical data that we have. And we are performing, we're then looking at the data that is coming in, what our sensors are telling us from the assets, and performing real-time predictions on top of that. This is our stack into, how we really help analytics processing. Like I said, we have a streaming processing block which uses Stream Explorer, and we also support Apache Spark streaming. You can actually perform batch processing. That is where, for example, you can create your own algorithms to create predictive models, to create anomaly detection models and stuff like that. Just to give you an example of how is that possible, let me switch back to one more demo. Whoops. So over here, what I'm showing is, IoT Cloud Services stream analytics capability. The blue pump that you saw over here, that you saw before, really, is actually being used as a source of data over here. And what we essentially do is, once we start getting data from devices, we view them as streams of data. So, we actually look at the source as a stream, really. Now, one of the things that I can do is start simulating data. So, I don't know why this is not coming up. Let me quickly start moving that. Okay. Sorry about that. The resolution wasn't helping. So let me start sending some data. And this is a simulator that is running, like I was telling you, it was running from my cloud service instance itself. So let me start sending some data. So this is my simulator dashboard. My simulator over here. And it's streaming in data right now. So once I go back to the Stream Explorer, what I'm seeing over here is real-time data that is coming in, and this you can actually do using a Raspberry Pi, for example. You can actually model your Raspberry Pi. You can actually set up different sensors on top of it, like Noel showed, and you can actually model them to send data upstream. So over here, we're actually getting data from your devices. We can actually look at them, graphically as well. And how do I really slice and dice the data next? So, what some of the capabilities that we provide is to really add filters on top of that. So, for example, I can say, I'm only interested in data which have an inlet pressure greater than, let's say, 300. So once I do that, what happens is, you would notice that I'm actually not showing the inlet pressure over here, but essentially, what I can do through this is really put different filters on top of the data that is coming in from our devices, and create these trend analytics on top of it. So, for example, I can say, hey, I'm only interested in looking at data which has, let's say, a pressure value reported by a pump greater than 300, has an electrical malfunction that is measured by some sensor value, and I can only, sniff for those messages. And what that helps me is I can actually use that message. I can actually use those patterns to detect issues with my assets, for example, and then send the data, integrate it with different cloud services, for example, Service Cloud, to actually create incidents based on the data that I have been observing. So this is one such capability of our streaming analytics. You can also choose, for historical purpose, you can actually choose to send that data to some storage cloud service so that, other services like Business Intelligence Cloud Service can use that data to perform, historical trend analysis. Now that we have looked at the analytics capabilities, let's look at, how does IoT Cloud Service provide you with integration capabilities. So, we have actually broken down integration into 3 layers. One is using our own provided adapters. We actually provide adapters to a lot of different IoT products. For example, EBS, JDE. Different cloud services, for example, Storage Cloud, the BI Cloud Service, the Mobile Cloud Service, for example. And these are all pre-built. You really don't have to do much to get started with these integrations. Once you have data coming in from your devices, once you have created your analytics, you can actually send those analyzed messages to any of these, any of these products, and perform any business processes that you may like. We actually provide a hook to Integration Cloud Service. Integration Cloud Service is, essentially a service that helps us get connected to external applications. For example, if you want to get connected to SAP or Salesforce, you can do that via our integration capabilities with ICS. And if you really want to customize everything, we actually provide appropriate REST APIs. So you can actually create a dashboard like the one that I showed in my previous demonstration, using our own REST APIs to really introspect the cloud service for any data, your device data, your analyzed data, what are the capabilities that are being exposed by that. And to get started, you have our enterprise client libraries to look at them. Some of the built-in adapters that we provide includes Integration Cloud Service, MCS, Storage Cloud Services. We actually provide integration, like I said, with other Oracle applications, for example, EBS, JD Edwards, Primavera, for example. And if you wanna, we actually have a lot of documentation on top of that. So, for example, all our client libraries that are written in Java, for example, are actually documented using JavaDoc. If you want to look at our REST APIs, for example, if you want to get started with our client libraries, we have a whole set of tutorials online to help you with that. We have detailed examples for different types of client libraries that we have. Also, this is our set of REST APIs. So if you notice, almost all the capabilities that I can do via the UI are actually possible using our REST API. So you can really customize and create your own dashboards and provide a simple solution based on the use case that you're targeting. So you can actually provide authentication mechanisms, your own custom authentication mechanism, your own custom way to of integrating your enterprise applications, for example. All of that is actually possible through REST APIs. So
I think we're getting close to the end, right?
Yeah. Any other thoughts from you?
Yeah, no, I mean, first of all, I want to thank you guys for being here. I think you guys are being smart. I can see, many years ago, people started analyzing the market with data that was, money data or market data. I think one of the futures, as he said, on the service part, now we have devices, cheap devices, technology that can be embedded into physical things, and we're going to be able to actually now track and get data from these devices. So I think as you guys are here, you'll become the subject matter expert of the future. So, as you get start implementing these solutions within your industries, your companies, it's just going to make more sense. And I mean, your CTO, CIO will know because of the savings that you can get. Other than that, I mean, I said IoT is demystifying. It goes, it can mean a lot of things. But for Oracle, we saw the advantage of having our infrastructure and our know-how, and instead of just creating just a key value database to store that, it's more than that. It's hardened, it's compliant, has all the libraries, which is very important because right now IoT has at some point has got to get some bad rep by security. You guys heard a couple years, in the past year or so, security cameras got hacked and blah, 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 it's all these things. But the IoT Cloud team has taken a lot of care in making sure that this is a hardened solution and it's ready for production. So I don't know, any questions you guys might have?
Any questions? Cool. All right, so that's all we had for today.
Yeah. So don't forget, thank you. Yeah, don't forget to come over here if you want to get a kit. It's self-paced, so you don't have to spend too much time. You can start, you can come back, and basically we have a table and we can help you go through the tutorials.
Yeah, please visit our IoT workshop. It's just right over there.
Around the corner.
Yeah.
All right, thank you.
Thank you.